I was trying to balance a broom upright on my palm in the kitchen yesterday. You know that feeling?
Yeah, constantly micro-adjusting your hand.
Right, shifting your weight just to keep it from toppling over. It takes um, active, constant energy.
That is the classic definition of an unstable equilibrium. The second you stop moving, well, gravity wins.
Exactly. And while I was doing that, I was thinking about the research we pulled for this deep dive. Because usually, space travel feels exactly like that broom.
You're either fighting to stay in orbit or you're firing engines to stop from drifting off into the void.
Right. But it turns out the solar system has a loophole.
You're talking about the Lagrange points.
Yes, the 5 parking spots where gravity basically creates a perfect cancellation. We're going to unpack how these invisible valleys work, why the James Webb Telescope hides in one, and this was the part that blew my mind, how a specific spot near Mars might actually let us terraform the red planet.
It really is a fascinating mix of orbital mechanics and history. We usually credit Joseph Louis Lagrange for the set, but he was really standing on the shoulders of Leonhard Euler.
Right, Euler actually found the first 3 points L1, L2, and L3 back in 1750.
And then Lagrange came in a decade later and did the math to find the stable ones, L4 and L5.
Before we map out where these actually are, I want to briefly mention our sponsor, Embersilk. We're talking about optimization and finding the perfect leverage point today, and that is exactly what Embersilk offers.
Oh, absolutely.
If you are looking to integrate AI training, automation, or software agents into your workflow, you really need to see what they're building.
It's all about finding that high leverage position to let the system work for you. Check them out at embersilk.com to uncover where agents can make an impact on your business or personal life.
So looking at the map of these points, let's start with Euler's discoveries, L1 and L2. The math described these as saddle points, which I thought was a great visual.
It's the perfect analogy. Imagine a horse saddle. It curves up in one direction and down in the other. If you are a satellite at L1, which sits directly between the sun and Earth, you are balanced on that ridge. You won't fall toward Earth or the sun, but if you drift sideways,
You slide off.
So they aren't perfectly stable.
Which explains why the DSCOVR satellite, which sits at L1 to monitor solar winds, has to burn a little fuel to station keep. It's doing the broom balancing act, just in slow motion.
But the payoff is incredible. Because L1 is upstream, it acts as a sentry. It detects solar storms about an hour before they hit Earth, giving our power grids a crucial warning.
Then you flip to the exact opposite side, behind the Earth, and you find L2, the darkroom.
Ah, yes, where the James Webb Space Telescope lives.
The key takeaway from the sources was that L2 is the only place where a spacecraft can block the heat from the sun, the Earth, and the moon all at the exact same time.
And that geometry is absolutely non-negotiable for Webb. It observes in infrared, which is essentially heat. If it were in low Earth orbit, the heat radiating from our own planet would blind its sensors.
So at L2, it can keep its back to the heat and face the freezing cold void to capture images from the dawn of time.
Then there is L3, hidden on the opposite side of the sun.
The ghost.
Yeah.
This is where pulp sci-fi writers used to love putting it counter-Earth,
The secret planet exactly like ours that we can never see.
which sadly the math completely disproves.
Right. L3 is incredibly unstable. If a planet were actually there, the gravitational tug from Venus or Jupiter would have destabilized it eons ago. We would see wobbles in other planets' orbits.
But L4 and L5, these are the real game changers.
The harbors.
Yes, they form equilateral triangles with the Earth and Sun. And unlike the saddle points, the research describes these as potential wells.
Exactly. If you nudge an object at L4 or L5, it doesn't fall away. It circles back due to the Coriolis force. It acts like a ball rolling around the bottom of a bowl.
And because they are stable traps, they collect history. Jupiter has over 1 million Trojan asteroids stuck in its L4 and L5 points.
It is nature's safe harbor. That stability is why the L5 Society specifically targets these points for space colonization. You could build massive rotating habitats there that float in fixed relation to Earth without needing constant fuel burns to stay put.
But the most optimistic proposal I read was about Mars. There's a concept to go back to the L1 point between the Sun and Mars and park a massive magnetic dipole shield there.
This is a brilliant application of physics. Mars has a thin atmosphere because it lost its magnetic field. The solar wind basically stripped the air away.
So you were essentially holding up an umbrella for the planet.
Precisely. If you park a magnetic shield at Mars L1, you deflect that stripping wind. Mars's atmosphere could naturally thicken over time due to volcanic outgassing.
You would trap heat, warm the planet, and potentially allow liquid water to flow again. It's terraforming, not by brute force, but by smart positioning.
Gravity builds the roads, we just have to drive on them.
I love that. It really makes you consider that gravity doesn't just pull things down. It creates this invisible architecture in the void. If L4 and L5 are nature's safe harbors, maybe they are our natural first stepping stones to living permanently off-world.
The pathways are already there.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.